In this video, we're going to measure powder and charge our 308 Winchester brass. As with all of our videos in this series, this is a beginner level video. We're going to go into a lot of detail. We're not going to talk about automatic powder weighing devices or scales that can throw charge after charge, because you really should have a hands-on approach and learn the basics before you start automating any process in reloading. We have two simple scales here, a digital scale and a balance beam scale. Neither one of them are very expensive. They're in the $25 or $30 range, and they're a great place to start. However, there's a caveat here, and that is that the scales are only as accurate as their calibration, and to refine that statement one step further, they're only as accurate as your ability to verify their calibration. Now, digital scales will come with a set of instructions and a calibration weight and a process whereby you would calibrate the scale, and you would think after it passed that test that it would be relatively accurate. The balance beam scales have an adjusting knob on them, so they could be very close or very far off of calibration, and the question is, how would you set that? And the only way you could set it is with some standard weight that you know the weight of. People use bullets, people use cases, but all of those things have considerable variability. The very smartest thing you can do when you're first getting started in powder weighing is to get a set of calibration weights. I personally like the Lyman 10 weight system. This is manufactured to a federal weights and measures standard that is extremely rigorous. According to my research, these weights individually could not be off by more than a few hundredths of a grain each, which means cumulatively, when you put a bunch of these together for a specific load, you're still going to be extremely close. Now, I want to show you what I mean by your ability to calibrate. I've already set this scale and calibrated it with its own weight. I've turned on the tare weight, and 32.6 is the load that we're going to measure, and we can't do that quite exact, but we can do 32.5 grains. So we're going to put a 20 grain and a 10 grain. We now should have 30 grains in here. This is a 2 grain weight, and this is a half grain weight. So we should have 32 1/2 grains. The problem is this scale reached 35.3 grains, even though it passed its own calibration setup system. Now, that's not altogether a disaster, because I know what that means. I know that 35.2/3 grains is equal to, or 35.2 or 3 is equal to 32.5 grains of the finished powder. So I know what it means, and so I can put powder in here till I get up to the 35.3, 0.4 area and know that I'm at about 32.5, 0.6 grains. Now, with the balance beam scale, this is adjusted a little bit differently, kind of like the weights in a doctor's office. This is in the tens. This is 0 grains, 10 grains, 20, 30, all the way up to 100. We're going to leave this at 30. This side is adjusted for 2.6. Now, we don't have 2.6 in the calibration weights, but we do have 2.5. So what we're going to do is transfer the 20, the 10, the 2, and the half, and we're going to put these on the balance beam scale. Now, with balance beam scales, the paddle back here is fluctuating between two magnets. That's what dampens this so that it doesn't take forever to settle out. That makes this practical rather than a real pain in the neck to take 5 minutes to settle out each time you put a weight in it. Now, you'll notice that the way this is settled out, let's zoom in so you can see this pretty closely. You'll notice that this is weighing just under the 32.6 grains that we've set the scale for. That's perfect, because we put 32.5 grains in the pan. So we know this is dead on, and we know that this scale has to read approximately 35.3 to 0.4 to be the equivalent weight. Now, The other thing to take into consideration here is how do you measure your powder if you're going to be doing this manually? Well, one of the ways is with little scoops or spoons. One of the ways that's a very traditional way of metering out powder is with what's called a trickler. This is a trickler. You'd put powder in the top. There's an opening into this threaded screw, and when you turn this, the powder kernels follow the threads in the screw, come up to the end, and then you get to a point where if you had a pan here, you could turn this very slowly and be trickling just a kernel or two or three at a time into that pan to finalize the weight. The problem with the tricklers, I mean, there's nothing wrong with them if you want to use them. I just don't personally use them, and I'll tell you why. One of the problems is from time to time I feel I need to move them. So if I were trickling powder here, I would want to move this to be able to get this pan out without knocking it around on things to pour it into the case. If you move this and you have kernels of powder literally to the very mouth, the occasional one falls out. And so over the course of a reloading session, you wind up putting little flakes of powder all over your work table and crudding it up. The other problem is if you reverse the trend to back them away from the screw, then you've got to figure out how to advance them to get them started again. If you go the wrong direction, you're actually deliberately pouring some out. I just think they're more trouble than they're worth, and I'll tell you why. There are scoops available, and as a matter of fact, the Lee die sets give you a scoop with each die that approximates the powder loads for that specific cartridge. In this case, it's the 308 Winchester, and this approximates it. And the reason it's approximate is because different powders are different densities, so different final amounts of this are going to be different depending on the selection of powder, but also because what we're doing is filling this to a range of powders. We're starting with the minimum, and then we're building up in small increments till we get to the actual combination that we like. So this isn't going to be exact, and this should never be viewed as exact. But what this is simply a convenient way to convey powder. And let me show you. If I take and fill this scoop, I've turned on the digital scale, I fill this near to full, and I start pouring this slowly into the scale, I will very quickly approach, it's 31.8, 0.9, 32, 33, 33.7, 34. Okay, I've hit 35.8. No. Yes, 36. So I've actually gone over. Now, if I was using the trickler, I'd have to not only move the trickler, I'd have to figure out how to get some of the powder out of the pan. With the scoop, I simply empty this in the canister, take a few kernels out, and then refine my load. As a matter of fact, I took out exactly the right amount. This is now 35.4. I use two scales when I do my weighing for one very simple reason. I transfer this over. It's faster, and it's more accurate. While this is actually settling out, I am already weighing my next load. So I don't have to wait for that and then empty it before I can even start my next load. I need a little bit more here. So this is going to come up to 32, 33. And you'll notice that one is settling out to almost exactly 32.6. We're at 34.9, 35.3, 0.6. This one went a tiny bit over. This one is good. This is well within 1/10 of a grain. If you want to be absolutely precise, you could put another kernel or two in this and let it settle out. And in this one, we need to take a kernel or two out to get back to the 35.4. Now, this is just about exact. So what we're going to do is we're going to put this spout over one of these cases. This is a good solid fit. We're going to take this powder. We're going to pour it into the case. We're going to give it a second to trickle through, and we're going to tap it to make sure we've gotten all the kernels in, because we don't want to pull this off and make an additional mess over here. We'll move it to the next one. I've already got 35.4 here. I move this to the balance beam. While the balance beam is settling out, I'm already in the process of beginning to measure my next case. So I'm going to finish up here. and I'm going to finish these 10 cases, and then we'll come back on to the video and show you what I do. This is a double test because we're using two different scales, and if something suddenly goes wrong, if the transfer of the weights doesn't make sense, I know something's been knocked out of calibration or some other problem has occurred, and I know to look further without making a mistake. If I'm using only one scale and something got a little bit off, I might not know it. I might not catch it until it was too late. The one thing you don't want to do is put significantly more or less powder in the case than the load calls for. So let's finish up this one load, and then when I have these 10 cases charged, we'll get back online here and show you how to finish up.